Good. We now know a bit about OCL, about the details of what is possible within an OCL expression. We have not looked so much into how OCL is applied. And in the use file, you find several places where OCL expressions are used. Namely, OCL expressions are used for derived attributes, for query operations, and for invariants. I have factored out the respective part here of the use file, and I will shortly explain how the OCL features that we have met so far are applied in these for these functionalities. So first of all, there is a so-called derived attribute in the class profile. The derived attribute is called initials. It is sort of, I've made the comparison to relational database systems with respect to the distinct and the duplicates in collections. There is also a connection between database systems and a feature of UML and use here. The derived attributes roughly correspond to what is called a view in a relational database system, or it's something similar. A derived attribute, there are also derived associations. A derived attribute is an attribute that is not explicitly stored, but a derived attribute is an attribute that is, when you use the attribute name, the attribute value will be calculated, and calculated by means of an OCL expression. So when we use the attribute initials, what is going on? We have an OCL expression that accesses the first name of the profile, that accesses the last name of the profile. And there are standard operations on strings in OCL. That's the substring with the lower and the upper index in the string that we want to consider. So we want to consider here exactly the first letter of the string. And we concatenate the first letter of the first name with the first letter of the last name, and then we get the initial. So this is the OCL expression that is here used in the derived attribute initials. There are query operations. In the class profile, we have two query operations. One query operation returns a set of profile, and the other query operation in the class profile returns a friendship in a particular way. The query operation friends, the intention is, I want to imagine I am a profile, a person which is participating in a social network, and I want to know my friends, namely those friends with which I have a friendship that is in the accepted state. And the friends can be people that I have been inviting, or the friends can be people that have been inviting me. So both roles, inviter and invitee, have to be taken into account. And it has. I want to know about only friendships that are in the state accepted have to be considered for this operation friends. So what this operation here does, and this operation considers the reflexive relationship friendship, and it considers a particular way that we have discussed before, where the role names are using the association class and the role names with which the underlying class is participating. So from the current profile, I'm navigating to the friendships which are where I am participating in inviter role, and I do a select now, and I'm selecting only those friendships that are in the OCL state accepted. A friendship can be in state pending, it can be in state accepted, or it can be in state declined. And I'm considering here only those friendships which are in state accepted. So this first part returns a set of friendships, and then I'm navigating from the friendship objects to the invitee. First, I am considering myself as an inviter, and then I'm going to my invitees, and I build the union with the dual case where I participate as an inviter, and then I build, I'm navigating to the inviters. As these operations, these dot things over here, this use of role names with a dot are return back valued, give a back valued result. I'm converting the back into a set as I have declared here this operation to return a set. And OCL in state displayed in gray because we have not encountered this option before. So you can ask an object in which state are you with respect to your respective state machine, and this is exactly what is used here. And well, two bags and or two sets, you can build the union of two sets or two bags, and that's what is going on here in the operation union. The other operation determines for a within a profile within the profile class, I've defined here an operation friendship where a parameter comes in. And the parameter is probably another profile object, and this is the profile object which I've. The parameter role is an inviter, and what this operation has to do, it should consider whether the current profile object on which this operation is called and the object here presented as a parameter, the inviter object, whether there is a friendship between the current object and an inviter object. The current object in the invitee position, an inviter object in the inviter position, and if so, it should return the respective friendship object. And this is done again by using here this construction where I navigate from the current profile object to the friendship object in my role as an invitee, and then I have a collection of friendship objects, and now I'm selecting a single object. Any is an arbitrary selection of exactly one object on the argument collection, and there can be only between two given objects. There can be only, due to this constraint considered later, there can be only either one, at most one link object between them, and if there is one, then I select this link object here with a friendship, and the friendship.inviter is equal to an inviter, which is a parameter. We will see more details about this operation later in the course. So this is an query operation that is defined in the class profile and which returns a single friendship object. This is a set valued result, and this is an object valued result. A single object is returned here. Okay, OCL expressions used for derived attributes, used for query operations, and of course OCL expressions can be used for invariants. In the class profile there are two invariants. The first invariant is the invariant asymmetric friendship, and the requirement here is that friendship is asymmetric. So I cannot be in connection with another profile both as an invitee and as an inviter. That is the intention behind this invariant that restricts the possible object diagrams, of course. The intention is there is at most between two profile objects, there is at most one friendship link. And this is guaranteed by the following requirement. Well, I'm navigating from the current profile to the invitee objects, and I'm navigating here to the inviter objects, and I take the intersection, and I require that the intersection is empty. So I cannot be connected to both through the invitee role and with the inviter role to a profile object. Intersection and union are common operations on sets and bags. The other invariant is a very standard invariant. Well, we want to have unique usernames. As we have seen it in the object diagram, the username was unique. The invariant was satisfied there, and we formulate it as follows. There's a particular collection operation for this requirement, so we say profile all instances, and well, it's very verbose. Is unique username. The username is unique for all profile objects. So there are it's not the case that there are two different profile objects which have the same username. The third invariant, we have discussed this quite in detail on one of the earlier slides. This is the requirement that a commenting for a posting can only be done by a friend. And yeah, we have discussed this in detail in a previous slide and in a previous session. The last requirement is that there should be no duplicates for the subject class. So the requirement here is an equality requirement. I'm considering subject all instances, and I count how many objects are present in subject all instances. On the left side of the equation, on the right side of the equation, I count something different. On the right side of the equation, I again have subject all instances. I take I take the attribute in class subject. There is an attribute subject with a lowercase name here. That's an attribute. And this is a dot shortcut here. So for all subject objects, I'm considering the strings that are representing the subject. And I'm removing here the duplicates with the S. So this is the dot shortcut returns a bag, and I'm converting the bag into a set. I'm removing the duplicates, and then I'm counting the strings which are here in the argument collection, and the counting here on the right hand side and the counting here on the left hand side, that should be identical. Let us have a look at an object diagram, at a system state where everything goes wrong, where all invariants fail, where all invariants are violated. So the first invariant fails, comment only by friend. There is only one posting here, and now there was one commenting from Putin on the posting of Merkel, but now there is a second comment here. Well, all violating parts in the object diagram are indicated with red parts, with red lines here. So this is the commenting that violates this constraint here. Well, Trump has commented the posting of Angela Merkel, but Trump and Merkel are not connected through a friendship relation, and not through a friendship relation that is in accepted state. And therefore this commenting here violates this invariant here. The second invariant, profile asymmetric friendship, also fails. I have placed here, so Putin and Trump, as we have seen before, are connected through a declined friendship. The role names previously were invitee on the Putin side and inviter on the Trump side, and now I have placed here the dual, the complementary role names with Putin inviter, previously invitee, and the friendship here is pending. But this is not possible. It is according to the invariant, to the constraint asymmetric friendship, because now this intersection between invitee and inviter is not empty. So the constraint fails exactly because of this situation here. The last, not the last, the third invariant fails. I have inserted here another profile object, and this profile object has the username Moody, and the username Moody was already used in the Merkel profile object, and so username Moody occurs twice, and this violates the requirement that we will have unique usernames. Last invariant that fails, subject no duplicates. We have realized this invariant here with the counting on the left hand side, where we were counting the subjects, and on the right hand side we were counting the set of the strings associated with the subject objects. And here we have, as previously, we have how many subject objects do we have? We have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5 subject objects as previously, and I have added another subject object, and this subject object has the subject horses, and the subject horses was already present here with the ID horses. Here I've chosen a different ID. So the counting, exactly this counting on the left hand side will yield 6 in this example, and the counting on the right hand side, because I'm removing here the duplicates in the strings, in the subject attribute, the counting here on the right hand side will yield 5, because horses will, the duplicate appearance of horses will be removed by this as set operations. Yeah, and this is an example or this is the use of the OCL expressions in our example, use of OCL expression as derived attributes, as query operations, and as invariants, and this sort of also closes our consideration and our plan. Let me jump to the respective overall slide. The aim here was to introduce to you UML with with a collection of diagram forms that are available in UML, and certain diagrams are available also in the use tool. And the aim of this first part was also to explain to you that the diagrams are enriched and are made precise by expressions written in the OCL constraint, in the object constraint language as part of the UML. And the example of our social network also pointed out that the UML-based specification environment, this tool, can be used in a particular way for exploring a model and for building system states and for checking whether certain invariants are, for example, for checking whether certain invariants are fulfilled or violated, and so positive and negative test cases for models can be built in form of object diagrams.